looking at our warm-up to exponent rules, I just want to back up to the idea that all of our exponents can be expanded. Like when we look at number 1 here, x to the 5th times x squared. For what we're doing right now, I want you guys to go right along with everything that I have. Just as a reminder, there's my x to the 5th. There's my x squared. So in the end game, what power is it of x? How many x's are being multiplied together there in a string? 7 of them. So in the end, our answer is x to the 7th power. Humor me here with this expansion. So what could we say about the exponents? What do we do with them when we see a certain base to a power, same base to a different power? How do we get this? We just added the exponents that we had on the other 2 pieces. Again, I want you to go right along with the expansion with me here. Now, in number 2, we've got something here, b to the negative 4th. Our b to the 4th, I could expand out to be b times b times b times b, right? When you have a negative exponent, what a negative exponent does is takes the reciprocal, or in this case, if it's b to the negative 4th, it winds up being 1 over b to the 4th. b times b times b times b times b. What would this work out to be? No, not 0. No, I don't agree. 1. Isn't it all of my b's divided out, top and bottom? The only thing I'm left with is 1. Let's take a look at the expansion for number 3. Hopefully some of this stuff is coming back to you guys. It's things we've done before. I'm going to wait until conversations end, and I want to remind you that maybe I let you choose your seats today, but I can see we're going to make some changes this week. Conversations shouldn't start as soon as I stop talking. Let's look at the expansion for number 3. I'm just going to rearrange some stuff. I'm going to take my 7 and my 5, and I'm going to stick them next to each other. And I'm going to do that because I can down the road multiply them together. I've got x to the 3rd and another x. I'm going to put those next to each other. This is like x to the 1st power. I've got y squared times y to the 9th. Now let's think about what we did on problem number 1. I'm going to get this 7 times 5 out of the way and put my 35 there. I have x to the 3rd times x, which is x to the 1st. X times another x is going to give me x to the 4th. If I were to expand out my y squared times y to the 9th, that's going to give me a y to the 11th. If I were to write those all out, that would get kind of long and ugly, but that's exactly what it would look like. Just like up on number 1, we added, when we had the same base, we added the exponents to get our product. Right here, our base of x to the 3rd times x to the 1st, x to the 4th, to the 2nd to the 9th gives us to the 11th. Number 4, one second, Taylor. Number 4, we have z to the 5th to the 5th power. This one gets a little interesting. Z to the 5th to the 5th power. That means I'm going to take z to the 5th, expand it with me. Z to the 5th, z to the 5th, z to the 5th, z to the 5th. There's z to the 5th to the 5th power. Now if I started breaking down all my z to the 5ths, how many z to the 5ths would I have in that whole product string? 25 of them. Exactly. So this one is called power of a power. When we have power of a power, we multiply. We have. That's why I'm warming you up pretty quick. Up here we did 5 plus 2 because it was a little bit different. It wasn't exponents and a power of a power. It was just a product. But down here we have power of a power. Moving along to number 5. In number 5, I've got this whole quantity to the 8th power. Let me, rather than, let's see, I'm going to write it this way. Show you as that's x to the 2nd to the 8th power. Let's take my y to the 4th. That's going to go to the 8th power. Take my m to the 3rd. That's also going to go to the 8th power. So let's think about what this would look like if I were to expand it all. X squared, x squared, x squared. I'd keep doing that, wouldn't I? X squared, and I'd have that sitting there 8 times. So what's going to be the power of my x? 16. Just like I saw up here, I'm going to multiply. But it's almost as if, I tend to not like to use this word, but it's almost like this power goes and gets distributed to everything inside. Distributive really only has to do with multiplication, but that seems to be an idea that a lot of people understand. What would be my power of y? 32, exactly. Y to the fourth, y to the fourth, y to the fourth. You know, 8, a string of it 8 times. M to the what? 24th. There you go. So there's my power of a power again. Number 6, taking a look at 6, x times x times x times x times x, all over x times x. I remember teaching this in Algebra 1 and talking about it. Yeah. I remember teaching and talking about this in Algebra 1. Once I divide out everything I can, that x and x, how many x's are, or what power of x is left, and then where is it? And it's in the top, isn't it? So it's like x to the third over 1, but I'm just going to leave it there as x to the third. I think these exponent rules, some of this stuff is kind of fun once you get the hang of it. Now, we're going to talk about this negative exponent rule again. This is probably the most important problem right here because I'm wondering if you had mastered the negative exponents. I'm going to rewrite my fraction right now. I'm going to leave my 5 sitting in the top. But what I had said about negative exponents is when we have x to the negative 4th, we need to treat that like 1 over x to the positive 4th. So that x to the negative 4th is going to drop into my denominator. My x to the negative 9th, 1 over x to the negative 9th, is going to turn into x to the positive 9th in the numerator. If you have a negative exponent, now notice I left my 5 sitting right where it was in top. That exponent did not affect the 5, it only affected the x. Left my 5 sitting right in top. Drop my x to the 4th into the denominator. My x to the negative 4th went down. X to the negative 9th went up. Now, if I were to expand all this, I don't know if I have to, do I? Where's my 5 going to be? Is it going to be in the top or the bottom when I simplify? It's not going to go anywhere. There's no reason. Talk to me about x's. Where are there more x's? The higher power? In the top in the numerator. How many more are there up top?
5.
That's where they're going to remain. And if I were to have written this all out, it would have looked like, I go and do it anyhow, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? 1, 2, 3, 4. X to the 5th and 5 are what remains in the numerator.